complete quadrilateral here. So ABCD and AB intersects CD at E. And AC intersects BD at a point. So we have a complete quadrilateral. Whoops. I don't know why, but I usually prefer, let me make these lines instead of rays, just because like I prefer seeing it like this for some reason, like where they intersect on the right. So I'll try to make AB like parallel with the screen, just because that's how I like to do it. And I kind of like that. It almost looks like AC is a diameter, which I don't want it to look like, but oh well. I think that looks okay. All right, so we have, this should be E, and that should be P. No, AC, sorry, that's E. P. Okay, this one I don't know if they even gave it a name. This is F. AC intersects CD at P. All right. And AP. Okay, so I think they messed up in the problem somewhere. AC intersects BD at P. And A, maybe they meant this one to be Z. Probably, I would guess.
No. Z
No?
EP intersection BC.
Oh, EP and BC. Okay.
And also just switch up BC and AD. So BC is at the bottom.
Okay. All right. So first I'm going to draw Z and then I'll do that. So that BC is at the bottom. A, B, C, D. Okay. So I guess, yeah, I'll make BC like wider than AD. And then, yeah, I should have made these lines instead of rays. Oh, well. So I will fix that. And then I'll redraw X. E. And this is P. Hey, Akan, how's it going? So we've solved 3 problems already. The first 2 are kind of easy. Although one used dual Desargues involution theorem, the third was like a little bit harder, but this one should be pretty hard because it's a riddle instead of a middle riddle. So AD intersects EBC at X and Y. Okay. So one of these is X and another is Y. Oh, we have isogonal conjugates. Okay. These have always been so hard, these isogonal conjugate problems. So we'll see what we can do with this one. Let's make it look nicer. So yeah, Hakan, if you know any lemmas on isogonal conjugates, besides the standard ones, that would be helpful here, probably. And if not, we will just solve it along with you. So this is E. And yeah, I feel like the best way to draw it is usually like I draw the pedal circle and then I take the center of it and then I reflect P over it. That's my usual way of doing it.
You didn't draw
I think
a
you
Z
should.
correctly.
Yeah, can you redraw Z?
Oh, Z is EP. Oh, you're right. Okay.
And you take isogonal conjugate with respect to ZXY.
Oh, okay. So I did the wrong triangle. All right. So this is Z. And then I have triangle ZXY. That's what I want to be doing the conjugate of. Okay. So let's draw the perpendiculars from P to each side. And then draw the center of that circle. And then reflect P over it. So we have 1, 2, 3. And then the center of that circle. And then if I reflect P over that, then I should get Q. Okay. This is a tricky diagram. So if how do I make P and J farther apart? That might be okay. So I'm going to reflect P about J. And that should be Q. And then fix the diagram. There we go. Okay, so let me see if I can still make it a little better. So we want to show PQ. It's the same as showing PJ bisects AD, right? We don't really need point Q if we don't want, but it might be helpful. Maybe something like that. So yeah, should I even draw point Q, or I could just hide it and well, I guess I could just leave it there. All right. Hi, Con. Thanks for joining us. Is this your first time on the session, or you've been on it before?
It's the second time.
Second time. All right. Well, good to see you again.
Thanks.
So yeah, this is our fourth problem. So yeah, we went through the first three pretty fast, although the third wasn't that easy. And now we're on the fourth. So yeah, we have the pedal circle of P, and we want to show if you connect it with the center. Wait, what's the point? Well, the pedal circle of P with respect to ZXY. And we want to show that if we draw the center then and connect it, then it bisects AD. So I wonder if we could kind of project if we draw the midpoint of AD. So we want to use that this is cyclic, right? So maybe drawing the center of the circle will help. We call it O.
Also, you should consider that circumcircle of X, Y, Z passes through the midpoint of BC.
Oh, that's true. Yeah. So,
Just keep that in mind.
all right. And yeah, I think that can be proven like using harmonics, right?
Yeah, I kind of forgot how to prove it, but I remember it is not hard.
Yeah. Isn't there some lemma like the midpoints of, what was that theorem? The midpoints of X, Y, AD. I think it's X, Y, AD, BD, and AC. Are those the midpoints that are cyclic? I forgot. I think it might be. So I don't know if this is really that helpful, but I think I think MKN are, whoops, MKN R is cyclic. Let's check it out. Yes. Then yeah, OL is obviously perpendicular to BC. So we know that F, Z, BC are harmonic, right? So if L is the midpoint of BC, then I think we have, what's the lemma? It's like LZ times LF is LC squared, I think. Let me check that that's true. But I think that's the lemma. So if I invert Z about that circle, then I would expect it to be F. Yeah. Okay. Oh, I think it's yeah, basically if B, Z, C, and F are in harmonic conjugation, I guess it's like a lemma that FC times FB is FZ times FL, where L is the midpoint. And once you have that lemma, you also know that FB times FC is FX times XY, so that proves that that's cyclic. Okay. So we want to show that P, Q, and K are collinear. I don't think PQ is perpendicular to BC, right? No, I don't think that could be true in general. Because it almost looks like it here, but
It is the median of PBC.
it's a median. Okay.
Yeah, because PK is the median. So
Yeah, because they're
those
similar.
PAD and yes.
Yeah. So we have to show that PQ is the median of PBC. I could try drawing the circumcircle of PBC. I don't know how much it would help. So, I mean, if we draw the tangents at B and C to that circle, where do they intersect? Like they're symmetric. Yeah, they intersect like really far away. So yeah, we want to show basically PJ is a symmedian or PQ, either one. Maybe it's worth like letting it intersect the circle at another point, and then we want to show that we have a harmonic quadrilateral. So we want to show PBMC is harmonic. We could also try to show BC is a symmedian of PBM. So we know PL, yeah, we know PL is a median. So that might help. We need a showing of BPL is CPJ. But yeah, how do we use that? Either J is the center of the pedal circle or Q is the isogonal conjugate. That's the tricky part here. Let's see. Can we say anything about the angle BPL? Or CPJ? Or we could try to show ML and MP are isogonal. Can we show EX equals EY? I actually think I showed that in a video on my channel before. I forgot the proof. But yeah, I believe that's the case. Let's think about why that would be. So it's the same as showing that, yeah, ZP is an angle bisector.
Inversion.
Inversion.
You invert at E with radius A, EA times EB.
Okay, so it swaps A and B, it swaps C and D, so that circle gets fixed. And then X and Y. Let's see. I wonder if that's just an angle chase, because so angle EXY is ECY, and that's 180 minus CDY minus CYD, which is 180 minus ABC minus XBC. Yeah, I think I have a feeling that's just an angle chase to show EX equals EY. But yeah, maybe inversion, like inversion fixes this circle. Yeah, I'm not 100% sure. Let's just assume that for now. So ZE is the angle, or ZP is the angle bisector of XZY. I think I can also define the circumcenter of ABC. Okay, so that's O, and show that AO and AD are perpendicular. Are you sure? So So O is the circumcenter of ABC, right?
Like I meant O prime, the circumcenter of EBC.
Oh, the circumcenter of EBC.
And
All right.
like EO prime is perpendicular to AD. It's the thing we want to show, which is just like angle NED is 90 minus angle EBC, which is 90 minus ADE. So EN is perpendicular to AD.
Okay. So yeah, EN is perpendicular to AB by that argument.
Which shows EX equals EY.
Okay. All right, I like it. ZE is not the angle bisector because Z is not on. Oh, you're right. Yeah. I got confused there. But yeah, I see that EX equals EY. And yeah, NE is perpendicular to XY. It's a good argument. So NO and L should be collinear. But yeah, I'm not going to make the diagram any more complicated. All right. So we want to show PJ is a symmedian. Yeah, what do we know? I feel like there's got to be some lemma about isogonal conjugates that would help here. So if Q, I wonder, let me think about this. So we have XZP is YZQ, and we want to show that BPZ is CPQ. I'm sorry, BPL is CPQ. Yeah, that changes things a little bit. What if I draw the midpoint of PM? I don't think that's that special. I mean, basically, I want to show BR and BC are isogonal, where R is the midpoint. What if I do a homothety at P that takes Q to M? What would it do to everything else? Don't know if that would do much. see what time it is. 10:51. So you have a little over an hour left. Yeah, this does look hard. So yeah, you guys want to try another problem? I feel like we've found a lot in the diagram, but it does look hard. What do you think? Okay. All right, I'll try a different one. Here's another riddle, so it's going to be harder again. But here's a middle riddle. So let's try this, and then we could try a riddle after. So we have, oh, this one was kind of interesting. I bet it's actually not that hard, but we'll see. So M is the midpoint of BC. And looks a little bit like the IM lemma.
Which lemma do you mean?
I'll mention it in just a second. So, oh, whoops. Let me call this something different. So basically, I just call it this on my channel. So IM bisects the segment AD. So I just call that the IM lemma. So IM, but we want to see this time. We want to see where it intersects AB and AC. So it's a little bit different. Okay. So let's see. Drag it down just a little bit. I want to see point D. Whenever I move the diagram slightly, point D goes away. So there we go. All right. So this should be X and this should be Y. And T is the midpoint of XY. And N is the midpoint of arc BAC when you draw the circle. We want to show that Tn is tangent to the circle. That's kind of interesting. All right, so this is going to be the midpoint of AD. I don't know if that helps. Maybe we have similar triangles somehow because we have two midpoints, three midpoints really. M is the midpoint, E is the midpoint, T is the midpoint. And MN is perpendicular to BC. Passes through the center of the circle. Call that O. Interesting. This is a good one. So if we want to show the distance from T to BC is the distance from N to BC. It's one way to think about it. And the distance from T to BC is the average of the distances from X and Y. So we know the distance from E to BC, that's half the distance from A to BC. Maybe we could somehow use similar triangles. NX and NY pass through the midpoints of arcs AB and AC. Interesting. Let's see if we can prove that, but that certainly sounds useful. And then we'd have like a harmonic bundle, right? Because we have a perpendicular, well, actually, would this necessarily be the angle bisector? I'm not sure. Just looked like it for a second. So why is that true? Let's see.
You mean NF bisects A and B?
So CF would be the bisector of ACB. Basically.
Oh yeah, yeah.
And then we could project through N maybe onto the circle. So then that would be equivalent to showing that, like I wonder if, oh, were you asking what I was asking if this was a bisector, an angle bisector? Okay, it's not an angle bisector, but maybe somehow this cross ratio. So NFG. Yeah, so maybe we can show the ratio, the cross ratio YXTM is the same as N or GNF in this point in the antipode.
Maybe use the fact that X, Y, T and point at infinity are harmonic and draw a parallel through N to that line.
Yeah, that's a good point. That might be a good idea. We could draw this point and this point. Okay.
And now it should be trivial to prove that FG and H is harmonic, right?
Yeah, so now, yeah, it would be true that, yeah, FG and H is harmonic. So yeah, I could draw on those segments if we want. Or yeah, it would be equivalent to showing that actually. Yeah, it wouldn't be. So what we could do is F, G, N, H. What if we project all those points through I? So F goes to C, G goes to B, N goes to the mixed to linear point, and then H, I don't know where that would go. That's the only thing. But then we'd have a different thing that we have to show as harmonic if we did that. So it would be BC this point and the mixed to linear touch point. We would want to show that that's harmonic.
We'd still know that the ones that aren't BC are parallel to MI.
Say that again.
The two other points in the harmonic bundle we want to show, the ones that aren't BC are still parallel to MI.
HN is parallel to MI.
Yeah, and now F and whatever the mixed linear touch point is would also have to be parallel to MI, right?
Oh, I think I
Oh.
see what you're
Oh, no.
saying.
Actually, I'm not sure.
So BC, this point, and this point right here. So like this may, I don't think this is necessarily parallel to MI. No. But yeah, if we could show LBKC as harmonic, that would also solve it.
I think there was another definition of L, like.
Oh, what?
Like, if you draw in the mixed linear in touch points, like to AB and AC, like AL and those 2 points were concyclic. Like that was a property.
Oh, so K is the mixed linear touch point.
Yeah, and if you let the mixed linear circle touch AB and AC at P and Q, for example, AL, PQ were concyclic.
Oh.
Like that, maybe we can angle chase and like solve the problem.
Okay. All right, so let's try that. Let's see what we can do here. So if I draw the mixed to linear in circle, so I could do it like this. Well, yeah, let me draw AI. Yeah, there's a lot of stuff here. So yeah, it should be the circle through these 3 points. To this, and this, that should be it. And so you're saying there's a lemma. So HI and L are collinear. Sorry. I don't think this necessarily passes through O. Yeah. So maybe I'll move it just a tiny bit so it doesn't look like that. I don't think I need point D. Okay, so P. So what were the 4 points you mentioned?
A, P, Q, L.
P, K, L, and A.
No. A, P, Q, and L.
Oh, A, P, Q, and L.
Yeah.
Interesting. Hey, Melek, thanks for joining. It's been a little while. So we're on our 4th problem, actually our 5th problem. So we solved the first 3, then we got stuck. And now I feel like we're making a lot of progress on this one. So, okay, so A, P, Q, and L are cyclic.
Like when L is the point making L, B, K, C harmonic. So we could just try to show Li, H are collinear.
Okay, so then we want to show Li and H are collinear. where IM is parallel to NH. That's how we defined it. All right. So yeah, if we can show, so showing HI and L are collinear. Let me think about that.
How do we define H? I just came back, so it's kind of
NH is parallel. NH is parallel to IM. That's how we defined it. So if we define H that way, I'm sorry, what did you say?
So you're saying that if Li and H is collinear, then the problem is solved, right?
Yes.
Okay. Can you explain to me how's that true?
So basically, Khan said that there's some lemma. The other Khan, he said there's some lemma that if P and Q are the touch points of the mixed linear in circle, and L, then ALPQ is harmonic. And so what we could do, we could project those 4 points through, I think it's through A onto the other circle. So that would be the same as showing that L, B, C, and this. Actually, can you explain it, Khan, a little bit?
Which part?
Sorry, let me think about this for just
why
a second.
L is the point making LBK say harmonic, or like why is the problem finished when L like H is common?
Yeah.
Oh, sorry.
Why is the problem finished?
So we defined L as the intersection of these two circles, right?
Yeah.
Okay. And so then you said it's a well-known fact that ALPQ is harmonic, right?
Yeah, like it's,
and
we can
then
use ratios because BP over CQ is BK over KC by KC, and like LBP is similar to LCQ, so LB over LC equals BK over KC.
Okay. Hey, Ibrahim, thanks for joining us. So we're on our 5th problem here. Okay, so, and then once we know that, so you just said the proof LP over PB is LQ over QC, and like we can eventually use that to prove that ALPQ is harmonic. Once we know that, how would you So we said that if we show Li and H are collinear, then that would prove that F and GH is harmonic, right? Oh wow, a lot of people joining. So how would that show that? So once we know that Li and H are collinear, how would that show that F and GH is harmonic?
Didn't we just project from I like L?
So L goes to H. Yeah. And then
like L goes to H, B goes to G, C goes to F, K goes to N.
Oh yeah, okay. So yeah, Con basically. So basically, B. Yeah, I got confused here. Wow, so many people joining all at once. All right, that's great. So basically, Hakan was saying it's well known that BI and G are collinear and that CI and F are collinear. So if we knew that ALPQ is harmonic and we project those through I onto the bigger circle, then L goes to, if we knew Li and H are collinear, L goes to H, Oh, you're saying it's well known that LBKC is harmonic. Sorry, so LBKC, it's well known that that's harmonic. And then you could project those all through I, then that would be equivalent to showing that NFHG is harmonic. Yeah.
Yeah, okay, that's complicated, but I like it.
Yeah. Yeah, I feel like there's probably a simpler solution, but I don't care if we find a complicated one, then it'll teach us a lot at least. So that's the good thing. All right. So LBKC is harmonic. Okay. Let's think about this. TA and KM intersect on the circle. Okay, so that's what Ryan just sent me. How did you get that? Okay, it's just similar triangles. Okay. So L, I, and H. How can we show those are collinear? So angle NHL is NKL, which okay, AXY and KBC are similar. Okay, AXY is similar to KBC. That's an interesting observation. I wonder if NA is like a symmedian in this triangle. I don't think it is, but I'll check it out. So we have angles YTN, sorry, YNT and ANX. And yeah, okay. So yeah, actually, it looks like NA is a symmedian in this triangle. I don't know if that's somehow obvious. Because we know NA is perpendicular to AJ, so maybe somehow by an angle chase we can show. I'm going to draw back in AD or AS. see. So this would be the midpoint of AS. Let's see. So yeah, I wonder if we show that if NA is a symmedian and NXY, I wonder if that would somehow solve the problem. Okay, so let's try to use this point R that Ryan just mentioned. So if we project ytx infinity through A, then we get BCR, and the parallel to IM is harmonic. So maybe we could use that. So if we draw, I kind of like that better because we know the parallel through A to IM goes through the topmost point of the incircle. We know a lot about this line right here. It goes through the topmost point and it goes through this point and this point. So basically, BCRW is harmonic, and W is like the reflection of K over NJ, I think. Maybe not. But so BCRW is harmonic. Yeah, but I don't know how much that really helps actually. Well, you could project through M. So if BCR does, do you think you've solved it?
Yeah, the LIH collinear thing. I think I've proven it.
Okay.
So I'm gonna let LI meet the circle at H, and then I'll prove that NH is parallel to IM.
Okay. All right. So I'm just gonna hide this for a second. So LI intersects at H. And then you're gonna show that NH is parallel to IM.
All right. So we have L is the center of spiral similarity, taking B to P and C to Q. So it's taking BC to PQ. So
Okay.
it's taking the midpoint M of BC to the midpoint I of PQ. So
Okay.
also this spiral similarity taking the point N, which is the mid arc, the midpoint of the arc BAC to the point A is the midpoint of arc PQ.
Okay.
So in other words, LIM and LAN is similar.
Yes.
So angle LIM is equal to angle LAN, which is equal to 180 minus LHN. So we're done.
Okay. So LIM is 180 minus LHM. Which
LHN.
LHN. So we've okay, and then so that proves the parallelism because LIM it's 180 minus LHN. Well, so basically MIH is IHN, and that proves it. Okay. All right, I think I got this. So I'm going to write this up. So yeah, I'm going to write like everything that we said was well known, and then in the very end, if we want, we can prove it. So let the mix the linear in the circle be, let the A mix the linear in the circle be tangent to AB, AB, AC, and ABC at P, Q, and K. All right. So it's well known that Ni and K are collinear. Okay, so
I think we should prove that the fact that NX passes through the midpoint of arc AB, because I don't think that is familiar.
That well known. Yeah, let's see if we can prove that. Okay. So I'm just gonna write out what we know or what we've done, and then we can try to fill in the details. So NX and NY pass through the midpoints of arcs AB and AC. Let's say the midpoints F and G of arcs AB and AC. So yeah, we can try to prove that. And then let APQ meet ABC at L. Then LBKC is harmonic. Well known, but we'll prove it. Or I'll just say well known for now, but we can fill it in just a second. So, and then we take that projecting through I. Whoops. Okay, so let LI meet ABC at H. And okay, so a spiral similarity. So consider the spiral similarity through L that takes PQ to BC. So it takes A and okay, so it takes LIM goes to LAN. It takes A and I to N and M. A and I to N and M. And that means that angle LAN is LIM. And that means that they're parallel basically, because angle MIN is 180 minus LIM. Well, LIM, yeah, angle MIH 180 minus angle LIM, which is 180 minus angle LAN, which is angle LHN. And that means that LI is parallel, or NH is parallel to IM. Okay, so we know that. And then now projecting through I. So yeah, I'll actually put that down here because then I can write that, and then we can project through I. And then, so since LBKC is harmonic, then projecting through I, NFHG is harmonic. Harmonic. And then projecting through N onto IM. We have YX I'll say YX, and then I'll say NN is like the tangent line at N, and then cap XY, comma. And that implies that NN XY equals T. And that means that Tn is tangent to ABC, and that solves it. All right. So let's see. I'll break this up into 2 lines and make it look a little better. All right. Need to put a few backslashes and add this and add this. Okay. So NN means tangent to ABC at N. Okay, so we still want to see if we can show that NX and F are collinear. So let's see if we can do that. That was what Hakan mentioned. Okay. So you could make room if we figure out the proof of that. And we also use this fact too, which I don't, yeah, Khan gave a proof of that.
I wrote solution.
Oh, you wrote the proof of that fact?
Yeah, you can just copy it in and just, read it.
Yeah, okay. So I'll say star, and I'll say proof of star. Yeah, I moved everything down, but I think I'm just gonna say proof of star. Star. Thanks for typing it all up. Let's think about this. So let me try to break this up into one more line. So BIC. All right. So by Menelaus, XA over XB times TD over TA.
T is the intersection of, that is point S.
Okay, so this is D right here. Okay.
Yeah.
So XA over XB times wow, a lot of people joining. So XA
Sorry, but T is actually the intersection of MI and AD, so we can call it another point.
MI and AD. Okay, so T, I'll change it in a bit. Let K
T prime maybe. Oh yeah, K. Let's call it K.
be the intersection of MI and AD. And then wherever I see T, I just make it K. So it's K, K. Yeah, there must have been a quicker solution to this problem, but I feel like I learned so much in the solution. So yeah, I don't mind that it's longer. Proof of star. All right, very cool. So I'm going to move on to the next. So let me think about this one a little bit first. So XA over XB times KD, strong point K. So this is K. So XA over XB is MD over MD. And then is NA over NB. Okay, so what are we trying to do here? We're trying to show that it passes through the midpoints. So are you saying if we show this ratio, that proves that X, N, and F are collinear?
My point was to prove that XA over XB is equal to NA over NB. So it must be equivalent to NX is the angle bisector of A and B.
I didn't even think about the angle bisector theorem. Okay, that makes sense. So IM, IN, IA, and ID are isogonal. BIC. So that's how you get those ratios. So they're isogonal. So IDM is similar to IAN. And then that gives you the ratios that you need. Wow, this is a fascinating solution. All right, I am going to move on to another one. Let's see. So we have about probably a little less than a half hour left. So this one, we could either go back to this one or we could try a new one. What do you guys want?
Try a new one.
A new one. Okay. All right. So we have a triangle ABC with circumcenter O. And we see where AO meets the circle BOC. Okay. I almost feel like it's like, yeah, like once you get to a certain level, it's like you can find these like really complex solutions to these problems that have easier ones, and it's like faster than finding a simpler solution. Yeah. Okay. So this intersects the circle again at X. Then we draw the altitude AD. And you drop the perpendiculars from D to AB and AC. All right. Let's see. Yeah. So, whoops. So E, let me make this a little better so that I can see point E better. Okay, so this is E and F. And T lies on EF, so that DT is DT is the reflection of DB over DE. Okay, so I want to reflect this line. So I guess this is point T. So it's like that's an angle bisector. And then this circle DEF intersects BC at S. So yeah, I can get rid of this. I mean,
I kind of don't understand the statement that DE and DF are perpendicular. So, like, does they mean that DE and DF are like perpendicular to each other, or they are perpendicular to the sides of the triangle?
oh, you're right. I think when I read the original statement on Discord, so this is 349. I thought it was perpendicular to the sides. Let me see. Riddle, sorry, this should be Riddle 329. Or what was it? Let me see. It's one of, I know it's one of the more recent ones. So yeah, this diagram, yeah, actually, I'm not sure. No, I think you're right, actually. I think DE and DF are perpendicular to each other. So let me fix that. So I guess then E can be any point. And then F, we want to be perpendicular. All right. And T lies on EF. So that dt is a reflection of dB over dE. So okay, let's see if we can make this a little better. Ideally, I'd like to make it so that I don't have to draw as much. So if I can make these intersect, that would be best. Yeah, I could do something like this. Sorry, I think there's like a cat or something outside. I don't know if you can hear it, but it's kind of loud. So T, this is T. So dt is the reflection of dB over dE. Okay, so this is like an angle bisector. And then we draw the circumcircle DEF, and it intersects BC again at S. And we want to show that T, S, and X are collinear. I feel like it might have been nice. It might have been easier if it said like, let SX intersect this at T and prove that this is an angle bisector. Like I think that might be an easier way to state this. So like this circle, we want to show DE as an angle bisector of T prime DB. This seems like a middle riddle, but maybe it's harder than it looks. So we know, like we have some angle ADF is BDE, right? Or do I have that right? Yeah, ADF is BDE. Yeah, and we want to show that's an angle bisector. So this is a circumcircle BOC. So BXC, BO is the angle bisector of BXC. That almost looks like a parallelogram, but it's not. So we have this as an angle bisector, and we want to show that this is an angle bisector. It's kind of interesting. So yeah, like X, no matter where E is, X stays in the same place. So yeah, you have this circle, and EF is a diameter of that circle. And X is always in the same place, no matter how you move E. But you want to show that if XS intersects the diameter at this point T prime, then you want to show DE is a bisector here. But this is a right angle, so I mean, we want to show that we have a harmonic bundle, right? We want to show that DT prime, DE, DB, and DF is harmonic. So can we project that? I mean, basically, if you let DT prime meet the circle again, then we want to show that EFS EFSG is harmonic. In fact, I wonder if G is just like the reflection of S over EF. It looks like it, yeah. Let me check that that's really true. But it appears that it is true. So really, we just want to show that, whoops, I deleted G instead of S prime. If we can just show that ST prime E is DTF, that would solve it. That would mean that these are reflections. Wait a second, was I assuming that T prime will, what was I doing? Oh, we want to, yeah, okay, we want to show this is an angle bisector. Which if you project, that would be the same as saying that that's harmonic and EF is a diameter. Yeah, so we want to show that those are reflections. That's the only way it could be harmonic. I wonder if AT prime, I don't think so. I was going to say AT prime is perpendicular to EF, but that's not true. Check the chat. Why all written?
Sorry. I think that if you let T be the actually let K be the midpoint of EF, then if we can show that KT prime DS is cyclic, then we are done. But it's not really easy.
Okay, KT prime DS. Would that help show? Okay, so if we showed that, yeah, if we had more time, it looks like a good problem. Like I definitely don't think it's impossible, but how would that solve the, because then angle T prime K would equal S DK. And we want to show, is KSD isosceles?
Actually, those 4 points are cyclic is equivalent to saying that the harmonic bundle you said earlier, because if we let EF meets BC at a point,
Mhm.
then we can show that EF T prime at that point are in the harmonic conjugation, because we have those 4 points lost in a circle.
So yeah, you're letting EF and BC meet at a point, right?
Yeah.
I actually thought about it a different way. So like, if we know this is cyclic, then since KSD is isosceles, right? Because K is the center of this, KS equals KD. So showing that this is cyclic, an angle chase shows that that's equivalent to ST prime E is DT prime F. And that is the same. That's the same as saying that GESF is a kite. So if GESF is a kite, kites are harmonic. And then what was I going to do after that? So give me just a second. Then we can take that kite. And if you look at through D, the pencil through D, then that means that DS, DE, DG, DF is harmonic. But since angle EDF is 90, then that means this is the angle bisector, which solves the problem. So I think I thought of it in a different way. But you were letting EF intersect BC, right?
Yeah, I did.
Okay.
Because I was thinking like when I define T as the original way. So yeah, I just let EF and BC meets and just use the harmonic conjugation. But the same thing goes with letting T prime be the intersection of XS and EF.
Okay. So we just have to show this is cyclic. And I wondered, I don't think these concur. No, I was going to say these looked a little bit like those might concur, but they don't. So ED okay. So yeah, K is the center of that circle. Maybe we could try to show HD times HS is HT prime times HK. We know HD times HS is HF times HE. Oh, so wait, so that means, does that mean that like we have some of these are harmonic? Because we want to show HF times HE is HK prime times HT. So that means we want to show HF, T prime, and E are harmonic. I think that's what you were saying, right?
Yeah, yeah. You can explain it that way.
Okay. But wait, we know that those are harmonic. Well, if I define T prime the way that I did, I wonder if I have a solution. Let me think about this. So, let me try to write this up. So let XS intersect EF at T prime. Okay. And then if we project, oh, wait a sec. Okay, I was projecting through D. Yeah, actually, I don't know that yet. Yeah, that wouldn't work. But yeah, I bet if we spent like an hour on this riddle, we could figure it out. But yeah, it was the last problem we worked on. So yeah, we couldn't finish it. But yeah, I feel like we got really close on this. Well, actually, I don't know if we got that close. But yeah, this solution I really liked right here. So I think the guy that proposed this problem would be really happy with this. All right, so we're out of time, so I'm going to stop here. But thanks everyone who participated on the session. We had a lot of people here today, so there was a lot of fun, and we had a lot of really great solutions. So if you're watching on YouTube, thanks for watching. If you want to join us, email me at mgreenb801@gmail.com. It's in the description of my video, and we meet every Sunday at 8 a.m. US Central Time. So thanks again and have a great day.